Good morning, students. Jai Swaminarayan. Now, instead of starting chapter 8, in this lecture, students, we are going to start miscellaneous exercise 7 and complete it in the next lecture, so that this is very useful to you students in the concept of probability. My motive to do miscellaneous exercise 7, whether it is there in the syllabus or not, students, that is immaterial. We have to understand the concepts, and we are, you can say, focusing on important types of sums where permutations and combinations are applied at a time. Now let us start the first sum. How many words with or without meaning, each of 2 vowels and 3 consonants, can be formed using the letters of the word daughter? Okay, students, we are given a word, say daughter. Four and 4, 8 are the total letters of the word daughter. Now we are going to use 2 vowels and 3 consonants. Out of this 8, we are to use 2 vowels and 3 consonants. So let us check how many vowels we have. The 3 vowels we have are A, U, E. So definitely we will have 5 consonants, which are D, G, H, T, R. Now this master key is universal for arrangement. We use permutation, and for selection we use combination. This is universal, and you have to apply the concepts based on this words only. So my first thing is selection. 2 vowels and 3 consonants can be selected in. Out of 3 any 2 vowels, selection means combination. Out of 5 consonants, any 3, so combination. 5 say 3, 3 say 2 is 3, and this is 10. That I am writing directly. So this is 30. Now you know how to simplify. 5 is 3, 5 factorial upon 3 factorial into 2 factorial. So first is selection, so combination. Now these 5 letters I have to arrange using 5 letters. Total words formed is equal to, now draw 5 boxes. Words means arrangement of letters. So we have 5 letters and we have to arrange all 5. So 5 letters can be arranged in 5 ways, and that is 120 ways. Into 30. So the total answer will be 3600. Why? Because first we are selecting 5 and then we are arranging 5. So for selection we have used combination, and then for arrangement we have used permutation. So I should have used like this only, students. 5p5 into 30, and that is 120 into 30, and that is 3600. This is, students, the concept involved in the sum. First we are selecting. After selecting we are arranging. So here we have a combined use of permutation and combination. A similar sum we will do together so that students you can understand. Which is 6. The English alphabet has 5 vowels and 21 consonants, that all of you know. We have 5 vowels and 21 consonants in English alphabets. Now, how many words can be formed using 2 different vowels and 2 different consonants from the alphabets? So, I have to select 2 vowels, I have to select 2 consonants. Now, I am directly assembling. So, total words formed of 4 letters using 2 vowels and 2 consonants equal to, first select 2 vowels, select 2 consonants and arrange this form. There I have shown separately. First it was selection, then it is arrangement. There students I have shown separately. Here I am clubbing and assembling it together. Now 5 C2 will be 5 factorial upon 2 factorial into 3 factorial, 21 factorial upon 2 factorial into 19 factorial, and this is 4 factorial. With that I am not simplifying. The simplification work is for you. Total words are 50,400. That is okay. The concept behind the sum is important. This part is very important. This is okay. You can do it using your calculator. So what is the point, students, in this type of sums? We have used permutation and combination at a time. We have used permutation and combination at a time. This type of sums are very important from examination point of view. Okay, now second sum. Sum number 2. Yes, students, sum number 2 goes this way. How many words with or without meaning can be formed using all the letters of the word equation at a time so that vowels and consonants occur together? This is also interesting. The word equation has how many letters count? 8. How many vowels? Vowels are E, U, A, I, O, so 5. And definitely consonants are 3. Which are those? Then Q, T, N. Okay. Now I have taught you in the revision lecture. In exercise 7.4, after we did the revision of entire concept, those who are to be kept together, we group them as one. So we write total words of 8 letters where all 5 vowels and 3 consonants are together is equal to. Now group 5 vowels as 1 and group 3 consonants as 1. Take this as only 1 letter, take this as only 1 letter. 2 letters can be arranged in 2 P2 ways, that all of you know. We have done the sum of 6 boys and 5 girls, where we had found out the arrangement where all girls are together, and we have found out the arrangement where all boys were together. Now we have to multiply by the internal arrangement of groups. These 5 vowels within the group can be arranged in 5 P5 ways and 3 consonants can be arranged in P3 ways. So total answer is 2 factorial into 5 factorial into 3 factorial. 120 into 6 into 2. So the total words form will be 120 into 12, so 14, 40. This is, students, our answer. So whenever we come across the sounds of words or letters or arrangement, by default, students, we have to use the concept of permutation. Okay, students, now the third sum. A committee of 7 has to be formed from 9 boys and 4 girls. This is also a very important sum for probability. Students, my main point was to do exercise 7 was to apply these concepts in chapter 16 probability also. We are given 9 boys and 4 girls. Data collection very important. 9 boys and 4 girls. A committee of 7 is to be formed based on the given criteria. In how many ways that can be done. Okay, a committee of 7 is to be formed. Okay, students. First condition, the committee has exactly 3 girls. Answer A. Committee has exactly 3 girls. Now this type of words has lot of implication in permutation and combination. This type of words has lot of implication in permutation and combination. If there are exactly 3 girls, then definitely we should have 4 boys, because the total members of the community should be 7. So indirectly this tells us that if there are exactly 3 girls, then by default there must be 4 boys. So number of ways of forming committee with 3 girls is equal to, now from 4 I have to select only 3 girls, so 4 C3 and missing 2. From 9 I have to select 4 boys. Now 4 C3 is 4, that all of you know. This is 9 factorial upon 4 factorial into 5 factorial. So this will be 4 into 9 into 8 into 7 into 6. This gets cancelled. This is 24. So this 24 and 24 gets cancelled. 9 is 72 into 7. So the answer is 5, 0, 4. That's all. So in how many ways the committee can be formed having exactly 3 girls? Answer is 5, not 4. Now answer B. This part is implication. Committee has at least 3 girls. Committee has at least 3 girls. Now this is very interesting. At least means minimum that much, more is allowed, less is not allowed. So if there are at least 3 girls, more girls are allowed, 4 are allowed. If 5 are there allowed, 6 are allowed. So here we could have 3 girls or 4 girls. Even we can have 5, the total available girls are only 4. So as per our given data, there are 2 cases. The number of girls can be either 3 or 4 because it is told at least. So one must focus on at least means more than that is allowed, not less. So total must be 7. So boys here will be 4 and here boys will be 3. So number of ways in which committee can be formed. Of forming committee according to given condition will be. Now 3 girls out of 4. So 4C3 and means into 4 boys out of 9. So 9C4 or means plus and or theorem and indicates multiplication or indicates plus. So here 4C4 all 4 girls and 9C3. Now simplification and leaving for you students, you have to complete. The answer comes out to be 588. Now that much I can expect from you students at this level. That you know how to simplify 9C4 which is 9 factorial upon 4 factorial into 5 factorial. And you know to simplify 9C3 which is 9 factorial upon 3 factorial into 6 factorial. 4C3 is 4 and 4C4 is 1. Okay, the third part, committee has at the most 3 girls. Part C, committee has at most 3 girls. Now these words are catchy. At least, at the most, exactly, these words are to be focused on. Students, these words are to be focused on. What do you mean by at the most 3 girls? Maximum 3 girls. You can have 2 also, 1 also, and no girls. But you cannot have 4 girls. So the first case is 3 girls, or 2 girls, or 1 girl, or no girls. So if there are 3 girls and we have total of 7, then there should be 4 boys. Then here there should be 5 boys. Here there should be 6 boys, and here all 7 must be boys. Because in total the committee must constitute of 7 members. We should have total of 7 members. So here number of ways of forming committee. Number of ways of forming committee is equal to out of 4, 3 girls and means into out of 9, 4 boys, so 9C4 or means plus out of 4, 2 girls and means into out of 9, 5 boys or means plus out of 4, 1 girl and out of 9, 6 boys or means plus no girls and 7 boys. So 4C0 into 9C7. This is simplified as 1632 ways. Now that much students you have to do alone. At the conclusion of the chapter, I did not simplify the formula of NCR. That students, all of you know very perfectly. Now next sum is also a beauty. Let us do sum number 4. Now students, dictionary. All of you are aware of a dictionary, and you would have definitely seen dictionary once in your life. When you open the first page, you will have words with A. In that also, in order, after the words with A, you will have words with A, B, A, C. The first, second, third, fourth, fifth, all letters will be arranged in alphabetical order, and that is called dictionary order. If different permutations of all the letters of the word examination are listed in a dictionary, as in a dictionary, how many words are there in the list before the words starting with E? Now students, the word examination, E-X-A-M-I-N-A-D-I-O-N, 3 and 3, 6 and 3, 9 and 2, 11. So this word examination has 11 letters. Now, if I write alphabetical order of letters, then first we will have A, then A again, then E, because we don't have B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is alphabetical order. Students, the meaning of alphabetical order is dictionary order. What meaning do you understand by alphabetical order? It's dictionary order. In this, A is repeated twice, I is repeated twice, and N is repeated twice. Okay. Now, what does the sum say? Once again, if the different permutations of the letters of the word examination listed as in dictionary, how many words are there in this list before the word starting with E? So before the words start with E, you will have words with A. Yes or no? So words starting with A. So A fixed and remaining ten. If I remove one A, then remaining 10. So this is fixed. A can be arranged in only one way. Now what remains? A, E, I, N, O, T, X. These are 10. So before the word starting with E, students, we will have words starting with A. That much you have to understand. So indirectly here we are told to find how many words start with A. Now, so the word starting with A will be 1 into, because this A can be arranged in only one. Now for this 10, we have I repeated twice and we have N repeated twice. So 10 factorial upon 2 factorial into 2 factorial comes out to be 907200. 907200. So this is 90,72,000 words. So indirectly this many words. Therefore 90,72,000 words will come before the words start with E. This is the main part of the concept. dictionary order means whatever words we form with the letters, there students every alphabet will come in order starting from A to X. So that is, students, the meaning of dictionary order. Dictionary order means, students, alphabetical order. So if I form a dictionary with this many letters, my first page will have letters with A, then letters with AA. My second page will have letters with this, after that E, then I, then M, then N, then O, then T, then X. So as per this alphabets, the last page will contain the words with alphabet X. That is what, students, we have to remember. So 90,72,000 words will precede before the words start with E. So indirectly, students, we have found out the words which were starting with A. Indirectly, what, students, we have done in the sum, then I can say we have just listed or we have found out the words, students, which are starting with A. Now fifth sum. How many 6-digit numbers can be formed using the given digits 0, 1, 3, 5, 7 and 9, which are divisible by 10, no digit being repeated? Okay, students, answer 5. Given digits are 0, 1, 3, 5, 7 and 9. Total, students, we are given 6 digits, 0 being even, remaining all 5 are odd single digits. So using these 6 digits, how many 6-digit numbers are formed which are divisible by 10? So students, here I have to consider divisibility criteria by 10. So I give the heading numbers of 6 digits which are divisible by 10 and repetition not allowed. And repetition not allowed means a digit cannot be repeated. So I draw 6 boxes according to the criteria. And main importance is only units place which must be occupied by 0. Say suppose this is the 6-digit number 3, 5, 7, 9, 1, 0. Definitely this number is divisible by 10. So students, what is the divisibility criteria for 10? Then the answer to this divisibility criteria is that the units place must be 0. So 0 is already occupied in the units place in 5 places in 5 digits, which can be done in 5 is equal to 5 factorial ways. So numbers of 6 digits which are divisible by 10 and repetition not allowed is equal to 5 into 1. So the answer is 120 numbers. So this is again a very simple but very interesting sum. Now 7 sum, students, we will do next time. Let us do the 8 sum. 7 sum is a bit lengthy, so I will do in the next lecture. Determine the number of 5 card combinations out of a deck of E2, which has exactly 1 king. Now this is a very simple sum, so I am doing answer 8. From a pack of 52 cards, I bifurcate as 4 kings and 48 others. Now we should have a 5-card combination. 5-card combination having exactly 1 key is equal to. So your selection or combination of 5 cards means exactly have 1 king and 4 other cards. This, students, you have to remember. You know, in a pack of 52 cards, we have 4 kings of each suit. We have 4 queens. We have 4 jacks. And students, we have 4 aces. So my 5-card combination must have exactly 1 king. So out of 4, 1 king can be selected in how many ways? Then the answer is 5C1 and 4 other cards. So 48C4. This is, and I should have 1 king out of 5 and 4 other cards. So for 4 other cards there is no condition. So from remaining 48 students we can have any 4 cards. That is the main part of the sum. Now NC1 is n, so 5C1 is 5. This is 48 factorial upon 4 factorial into 44 factorial. And simplifying this turns out to be 7,78,320 ways. We can select in this many ways. We can select a combination of 5 cards which includes exactly 1 king. Suppose you are told to find a combination of 5 cards exactly including 2 kings. Oh, sorry students, I am mistaken. Sorry students, I should have written here 4 kings. Sorry students, I am sorry. There are, sorry, by mistake I wrote 5. There are only 4 kings. Now if you are told to find a combination having exactly 2 kings, then 4C2 into 48C2. Then what is the concept? 4C2 into 48C2. Exactly 3 kings. Then 4C3 into 48. Exactly 2 kings, so 4C2 and the other 3, so 48C3, like that. 4C2 into 48C3. Okay students, hereby we conclude the lecture. Remaining we will take in the next lecture.